Landing gear systems. Aircraft landing gear supports the entire weight of an aircraft and attached to primary structural members of the aircraft. Most landing gear have wheels to facilitate operation to and from hard surfaces such as airport runways. Provides a mean to absorb unusually loads incurred during landing and ground operation. Provides maneuverability for ground operation. Regardless of the type landing gear utilized, shock absorbent equipment, wheels and brake, retraction mechanisms, controls, warning devices, cowling, fairings, and structural members necessary to attach the gear to the aircraft are considered parts of the landing gear system. Design considerations of landing gear: maximum strength, minimum weight, high reliability, overall aircraft integration, low cost, airframe compatibility. Landing gear should locate near the center gravity of the plane. CG locations are dependent on aircraft configuration, loading fuel, and stick. There are three types of landing gear. These are tailwheel type landing gear, tandem landing gear, and tricycle type landing gear.
Tailwheel type landing gear. The tailwheel type landing gear is also known as conventional gear because many early aircraft used this type of arrangement. The main gear are located forward of the center of gravity, causing the tail to require support from a third wheel assembly. A few early aircraft designs use a skid rather than a tail wheel. This helps slow the aircraft upon landing and provides directional stability. The resulting angle of the aircraft fuselage when fitted with conventional gear allows the use of a long propeller that compensates for older, underpowered engine designs. The increased clearance of the forward fuselage offered by tailwheel type landing gears is also advantageous when operating in and out of non-paved runways. Today, aircraft are manufactured with conventional gears for this reason and for the weight saving accompanying the relatively light tailwheel assembly. Tandem landing gear. Few aircrafts are designed with tandem landing gear. As the name implies, this type of landing gear has the main gear and tail gear aligned on the longitudinal axis of the aircraft. Sailplanes commonly use tandem gear, although many only have one actual gear forward on the fuselage with a skid under the tail. A few military bombers such as the B-47 and B-52 have tandem gear, as does the U-2 spy plane. The VTOL Harrier has tandem gear but uses small outrigger gear under the wing for support. Generally, placing the gear only under the fuselage facilitates the use of very flexible wing.
Tricycle type landing gear. The most commonly used landing gear arrangement is a tricycle type landing gear. It is comprised of main gear and nose gear. Tricycle type landing gear is used on large and small aircraft with the following benefits. Allows more forceful application of the brakes without nosing over when braking, which enables higher landing speeds. Provides better visibility from the flight deck, especially during landing and ground maneuvering. Prevents ground looping of the aircraft. Since the aircraft center of gravity is forward of main gear, forces acting on the center of gravity tend to keep the aircraft moving forward rather than looping, such as with the tailwheel type landing gear. The nose gear of a few aircraft with tricycle type landing gear is not controllable. It is simply casters as steering is accomplished with different braking during taxi. However, nearly all aircraft has steerable nose gear. On light aircraft, the nose gear is directed through mechanical linkage to the rudder pedals. Heavy aircraft typically utilize hydraulic power to steer the nose gear. Control is achieved through the independent tiller in the flight deck. The multiple wheels spread the weight of the aircraft over a larger area. They also provide a safety margin should the one tire fail. Heavy aircraft may use 4 or more wheel assemblies on each main gear. When more than 2 wheels are attached to a landing gear strut, the attaching mechanism is known as a bogie. The number of wheels included in the bogie is function of the gross design weight of the aircraft and the surface type on which the loaded aircraft is required to land. The tricycle type landing gear arrangement consists of many parts of assemblies. These include air hulls or hull shock struts, gear alignments units, support units, retraction and safety devices, steering systems, wheel and brake assemblies, etc.
Fixed and retractable landing gear. Further classification of aircraft landing gear can be made into two categories: the fixed and the retractable. Many small single-engine light aircraft have fixed landing gear, as do a few light twins. This means the gear is attached to the airframe and remain exposed to the slipstream as the aircraft is flown. Retractable landing gear stow in a fuselage or wing compartment while in flight. Once in these wheels well, gear are out of the slipstream and do not cause parasite drag. Most retractable gear have a close-fitting panel attached to them that fares with the aircraft's skin when the gear is fully retracted. A small smooth profile to the oncoming wind greatly reduces landing gear parasite drag.
Shock strut operating and servicing. The compression stroke of the shock strut begins as the aircraft wheels touch the ground. As the center of mass of the aircraft moves downward, the strut compresses, and the lower cylinder or piston is forced upward into the upper cylinder. The metering pin is therefore moved up through the orifice. The taper of the pin controls the rate of fluid flow from the bottom cylinder to the top cylinder at all points during the compression stroke. In this manner, the greatest amount of heat is dissipated through the walls of the strut. At the end of the downward stroke, the compressed air in the upper cylinder is further compressed, which limits the compression stroke of the strut within minimal impact. During taxi operations, the air in the tires and the strut combines to smooth out bumps.